So my first question is just a big open one. Why did you create your own pump?
Mostly because of the failures.
And try to be a little bit politically correct here.
I will be.
Hello and welcome to Boat Talk, where we talk about all the ings of boats, as in repowering, building, operating, and this week, founding and developing. We are your hosts. Between us, we have more than 20 years here working at Seaboard Marine with Tony Athens, who's going to be on the show later today.
Yes, he is. In the flesh.
With me is the VP of Operations, Corey Schmidt. I'm Justin Riggy, the VP of Manufacturing. These days, we just get so many calls and emails from customers. We know you guys all want to be able to just call and have us pick up the phone, but it's been just chaos.
You should have a phone right here.
Right?
A red phone.
You're on hold right now because we're sitting here doing this. But we're trying to broaden our reach, so we're trying to answer these questions so you guys can get this information. There's not enough of us to go around for all the calls.
We're here for you.
Yep. So if you'd like to be a guest, email us at boattalk@sbmar.com. Please submit your ideas. We need ideas. We need emails. We need questions. We need topics. We need Between Two Stern, the funny segment, funny
Send
stories.
all the stuff, the goods, the bads, the funnies, everything. Send it all.
Yeah. So you can get us at boattalk@sbmar.com.
Write that down.
Okay. So now we got a special guest on the show, a man who needs no introduction here at Seaboard Marine, especially with our audience. He's a master contributor to the many forums, Boat Diesel formerly, and now our own forum, the Cummins Marine Group.
Cummins Marine Community.
And he's perhaps the only non-employee to be a Cummins certified applications engineer. I got that right?
That's correct.
Outside the box thinker, problem solver, boat builder, the founder of Seaboard Marine, and most importantly, the snook slayer.
Snook Slayer.
You got to put the picture up of the snook.
Well, we've built him up so much. Did you strap him down so he doesn't float away? Good.
So I thought what we do, since we're still getting this ball rolling with this whole podcast, we'd start out, we've been doing How We Got to Now. And so I thought we'd do a little How We Got to Now part 4 with Tony. And so I just wanted to ask you a few questions about how we got to now with Seaboard Marine. The first question is, can you tell us a little bit about Seaboard, how it got started, and how did you wind up in the boat business to begin with?
Well, it goes back to my younger brother who decided that he wants to get into the commercial fishing business. And with that said, he thought that I should get involved with him and we should develop a boat or build a boat that would allow him to commercially fish and make a living. With that said, when I started looking at what was available, what we could do, it really came down to we needed a reliable boat that wasn't based upon outdrives because of their complete lack of ruggedness. They just didn't hold up. So we started looking at, the first thing I did when looking at a boat was try to understand a very strong powertrain. And the size of the boats that we were looking at were all in the 25 to 35 foot range. And V-drives kind of popped up, and we had purchased a boat with an outdrive on it and had used it for a while and realized that it just wasn't going to cut the mustard. So we decided to get a new boat, and the first thing we did was I put a Walters V-drive in it. And that really opened my eyes to what you could do with a smaller boat, as far as the layout, how reliable it was for the long term, commercially efficient, yada, yada, yada.
Was that a Cummins in that first boat?
The very first V-drive we put in was we couldn't afford a Cummins engine. We bought a 55 horsepower Ford Lehman.
Okay.
The old trusty steed.
We had to run it at close to full throttle, and it worked fine. We got our 9 knots every place we went. Yeah. And believe it or not, we actually had a 2-blade 22-inch propeller on it.
Oh, wow.
We took a 4-blade propeller. It was too much propeller for the engine. I cut off 2 blades, took it to a prop guy, had it rebalanced, and It worked great for thousands of hours.
Wow.
Thousands of
Just
hours.
put an egg beater on there.
Right, we put an egg beater on there.
Yeah.
Then we finally decided that we'd wore out this 55 horsepower engine, and Cummins had recently released back in the 80s a 4-cylinder, a 4BT.
Right. We're
At
going to talk
that-
about that more
right.
later too.
That particular 4BT was released as a 105 horsepower engine, and we bought it, we put it in there, had to remount a bunch of things, but it turned out great.
Doubled your horsepower.
It doubled my horsepower. That's exactly right.
So that leads me to my second question. How did you wind up getting in with Cummins? What
Oh,
it just came out, it just looked attractive to you, or what?
You know, I just started looking around. I looked at Perkins. I looked at what was available, what was more modern, and I didn't know much about Cummins. Just started researching them, and they just kind of popped up, and I was able to hook up with a guy in those days called Ernie Murray, and he sold me an engine, and from there, it grew from there, the Cummins part.
Okay.
And I'll never look back as far as the choice that I made. It was the right choice. It's still the right choice. But it's not just based upon it's not because it's necessarily a better engine. You can support the engine,
Right.
and that is the key. You can get the parts.
Absolutely.
You can modify things. You can just do all sorts of things with it that you just can't do with other engines.
Yeah.
And really, it hasn't changed today, even with electronic engines.
Right.
You can support the product.
Right. That's key.
Right, that's the key. If you can't get somebody on the phone that can answer your questions and you can get the parts, then you're buying the wrong engine.
Right.
One of the things that I figured out a long time ago was this: if the engine is on highway in this country, especially the state of California, you can get support. If you can't find the engine on highway, my suggestion is don't put it in a marine vessel.
Right.
Because it's just not, the population isn't out there to support the product.
Right.
It's as simple as that.
So how did the transition happen from, building boats and work? You probably did some repair work and stuff in the early days. What got you into the parts game? How did that just out of demand? People kept asking for parts, or?
The parts game, I don't know what the term is, but it grew as the engine population grew. The engine population that we supported grew. We found that people that ended up buying an engine from us liked us to be able to support the engine. So as the use of the engine went up, we realized the parts that had to be replaced. Not because they broke, they're just the way in the marine environment, things just wear out, literally wear out.
So you just started stocking certain common
Right,
parts.
and we also started looking at making certain parts that were hard to get. Plus, we saw some improvements could be made in some of the off-the-shelf
Right.
parts. I think the first part that I started looking at really closely to make it better was the water pump.
Yeah, we're going to talk about that in a bit. So,
Okay,
Yeah.
the seawater pump.
Yep. Yeah, I got a bunch of questions
Okay.
about
We're going to
that.
dive deep on
Yeah,
that.
we're going to do a deep dive in the SMX 1730 pump. We're going to dive back into the SMX pump in a bit, but I wanted to get to a few of the emails and questions we've had, and I thought, Tony, I have a couple that have come up since the last couple episodes. We had an email from Bob, who has a Bertram 31, and he said, I'm looking to smooth out my Cummins 4B, which relates right to what you were just talking about, one of the first engines you dealt with, in my 31 Bertram at idle. Anything over 850 is smooth, but at idle, it's a little angry. They tell me it's the nature of the beast, right? That's why they call it the paint shaker, right?
Angry. That's a good describing word.
But I raised the RPM to 700, and that made it a little better, but I'm trying to make it as smooth as I can. Let me know what recommendations you have. And thanks, Bob. And when he and I have gone back a little bit back and forth with email, I told him he could maybe try some new isolators, but I also told him that's just kind of the nature of the 4B engine. What do you have to add to that?
The best way to look at a 4BT Cummins is the fact that it's a very unrefined engine. It doesn't have counterbalancing like a lot of four-cylinder engines do, such as even Perkins used a counterbalancing decades ago.
And the new B 4.5, does that have a counterbalance shaft?
Yes and no. It's offered both ways.
Oh, it's offered both ways. Okay.
It's offered both ways. But the original mechanical 4B is a very crude engine, very rugged. It's pretty hard to break, but it can rattle your fillings out. There's no doubt about it. As far as making it a little bit more comfortable in a Bertram 31, You have a little bit of advantage over smaller boats because the Bertram 31 does have the room in it to stuff in a 6BT. So that gives you about an extra 10 to 12 inches to work with over the 6BT. And with that said, the engine could be isolated better with proper mounts and possibly even a thrust block behind the engine that carries the thrust, and the engine could that be free floating on very soft mounts.
Oh, okay.
But again, engineering wise would require a lot of work, and the expense would probably be, by the time the dust settled, and that's if you did most of your own work, you could probably spend $4,000 to $5,000 per side by the time it's done.
So you're saying you're making the engine float on such soft mounts that it's going to kind of lurch forward, and so you engineer engineer a sort of backstop.
There's not going to be any thrust on it, so it's just
Right.
going to sit there and rattle
right,
away.
yeah.
But we can absorb the vibration. But linear vibration is energy that you have to dissipate. To dissipate it, you got to allow movement. For that when that movement takes place, there's heat that's developed within the isolator system. So you have to put in quite a bit of isolator to absorb that. And then the thrust block itself is going to be semi-rigidly mounted to the boat, and that's what's going to push the boat. So it has to have very strong mounts that can literally take the thrust from the propeller and push the block that's attached to the stringers that's going to push the boat.
Yeah, I'm sure we're going to get some questions about this, but
Again, it would not be for the
faint of heart.
Yeah, not for the faint of heart to do a job like that.
Your everyday DIY project.
Right.
Okay, another one I wanted to talk about is in our first episode, we talked a lot about propping. We specifically talked about propping trawlers, and we also talked about fuel burn rates. Also, when we had Jim here, we talked about the difference between mechanical engines and the electronic engines, and all the different, all the more data that you have, the real-time fuel burn rates. I see a lot of questions in the forum and just out there where people keep referring to load, and I know that we always tell people, forget about load, just look at the fuel burn chart, right? But I wanted to get your perspective a little bit on what is load and why should we ignore it? Or when should we not ignore it?
You should always know about load, know what your load is. But the digital instrumentation that just about all manufacturers, especially Cummins, puts on their engines, they tend to overstate the load percentage as far as being important. And the reason being is load percentage is more of an algorithm. And that algorithm is based on a lot of different parameters. Just the throttle position that you have to move the throttle to affects that. That doesn't mean the RPM changes, it's a position of the throttle.
Right.
The other thing that affects the load percentage is the fuel burn rate, okay? The fuel burn rate is going to be tied only to one thing and one thing only: the horsepower that the engine is trying to produce or is producing.
Right.
And for just a rule of thumb, I've always used this number. For every 20 horsepower that the engine is producing, it doesn't matter what RPM it is it's producing it, it's about 1 gallon per hour. So if you're using 5 gallons per hour, your engine is producing 100 horsepower.
Right.
Okay. What you're doing with that horsepower is just about always turning the prop. How fast the boat goes at that 100 horsepower input is going to depend upon mostly the weight of the boat and then the hull configuration itself.
Right.
And then you throw in things like windage and stuff like that. So when a person comes to me and says, hey, I have a 350 horsepower Cummins B series, I'm thinking about upping the horsepower. Okay, the first thing I ask them is, let's find out how much your load is now based upon your fuel burn.
Right.
Now that's difficult on a mechanical engine because most guys don't have
Real-time fuel.
type fuel.
Yeah.
Now, when you start talking a QSB or a QSL, which is a current subject on the forums, a guy's wanting to up his horsepower, and I'm questioning why.
Right.
Do you really need to?
Do you ever use all the horsepower that the thing makes?
Right. If you're not using the horsepower now that it makes, let's just use more of that horsepower before we start changing ECM parameters and stuff like that. So really, it all comes down to, how much fuel you're burning at what RPM, and how much fuel do you want to burn to go that extra 2 or 3 knots.
Right.
You want to go 2 or 3 knots faster? Everybody does. But if that 2 or 3 knots adds another $30 an hour to your fuel burn,
Right.
to your fuel bill, maybe you don't want to go that much faster.
Right. Yeah.
And again, the cheapest way to do it is by using more of the horsepower that you already have instead of reprogramming the ECM.
One thing I think a lot of guys just don't get is that their boat's going to take a certain amount of horsepower and fuel burn to go a certain speed. And just because you crank up if you have a 380, let's say QSB, and somehow you pump it up to 4, or you drop a 480 in there, it's not going to magically make the boat burn less fuel at that cruise speed just because you have the potential to have more horsepower. It doesn't change anything down low.
We also have to
That is
accommodate the
correct.
RPM difference as well. A lot of these ratings have different RPM ranges
Right.
too, so
But
it gets more complex.
It doesn't really matter which QSB version you buy, whether you buy a 5.9 330, a 5.9 380, a 5.9 440, or a 6.7 425. If you need 100 horsepower to move your boat the speed you want to go, you're going to burn 5 gallons an hour.
Right.
It's as simple as that.
Right.
Okay, plus or minus a couple %. If you want to go faster at the same weight, you're going to have to burn more fuel.
Right. Period.
Period. It's simple
Yeah.
as
Another way
that.
to do it.
Yeah.
Because a boat, the power and versus the speed of a boat does not climb like a simple angle.
Right.
It goes up kind of exponentially.
Sure.
Yep.
You know, you can go 12 knots at this, you go 13 knots a little more, but 14 knots all of a sudden it starts really going up.
Right.
And you got to balance that with your wallet. It's
Right.
as simple as that.
Going back to the original question, is there any circumstance, if you're running a boat where load percentage would be valuable in any sense? You guys
Yes.
seem to rely on it
Yes.
heavily, but is there
Yes.
any circumstance where you're like,
Yeah.
I really want to know what my load percentage is and how it works?
Well, if you understand what load percentage is, then it can mean something to you.
Sure.
Load percentage is really a measurement of the horsepower that the engine is capable at that RPM. At full RPM, it's capable of its rating. But you can also develop that same amount of horsepower at a lower RPM. So let's just say you have something fixed in your mind that you like to run your engine at 50% load, okay? But you have to put that 50% load in perspective at the RPM that you want to run at versus what the engine could produce. Let's take an engine that I know pretty good, which is the 425
6.7.
The slim line,
Yeah.
6.7.
Good
Yeah.
motor.
It's capable of producing 119 horsepower at 3,000 RPM.
419 horsepower.
419 horsepower.
Brake horsepower. Yep.
Brake horsepower. Now, if you drop down to 2,000 cruise, let's say, it's probably capable of still making over 300 horsepower.
No, 15 gallons an hour.
Right. I don't have a graph in front of me, but probably that.
Yeah.
Now, but that's what it's capable of making. So if you put the engine at 2,000 RPM, put a clamp on the propeller shafts, and put the engine at full throttle and started clamping the propeller shaft down to where it literally drug the engine down to that 2,000 RPM, you're at 100% load.
Right.
Because the engine cannot produce anymore. But if you loosen that clamp and let the propeller spin easier okay, you're still at the same RPM, your load percentage is going to drop.
Right. So load percentage is basically a meter of what you're using against how much can you use.
Produce at that RPM.
Now let's talk about something that we see a lot. Guys we get calls occasionally where they say, my load percentage at idle is really high.
Okay,
Mm-hmm.
that is
Okay.
a real
Yep.
easy one to
Right.
answer.
Sure.
At idle speeds, 600, 650, 700, the engine can't really produce a lot of horsepower. But if you put it in gear, let's say the engine can only produce 18 horsepower at an idle. Okay, you put it in gear and you're idling in the harbor, you might be using 60 or 70% of that available horsepower.
Right.
You put it in reverse at that idle speed, all of a sudden you're going to be using 100% of that horsepower.
Because the boat's not efficient going backwards.
Right.
And you're trying to slow it down.
Right.
So all of a sudden you're going to see these crazy percentages. Hey, when I cruise, I only cruise at 40%. But when I'm in the harbor, I'm running at much lower RPM. I'm running at 60 or 70%.
Right.
It's because the engine cannot produce much horsepower
At that RPM.
At that RPM.
Okay, good.
So
Nice.
again, it's all based upon what it could produce at that RPM versus what you are using.
Now,
Perfect.
does load or does it not take into consideration the throttle position as part of that algorithm?
Absolutely. And here's a way you can maybe understand that. Let's take a generator engine that has digital instruments, and let's say you're running it at you're running a constant speed of 1800.
Right.
Okay, you have a 100 kW generator that's capable of 100 kW at 1800, and you're asking 30 kW at that time.
Right.
As you increase the load, start turning off on more appliances, the load percentage is going to go up,
Right.
okay, versus the RPM is going to stay the same. So I'm not sure. Was that answering the
Yeah,
question?
yeah.
Well,
Because what the generator the control has to, the governor has to increase the throttle.
Right.
to-
It's
to
increasing
maintain to maintain
whether
the
it's
RPM.
doing it
Right.
externally, actually on generator, it's doing it internally. the
Internally,
throttle.
right. But
And
it's
so-
applying more fuel to
Right.
accommodate
It's
the
applying
load.
more fuel by an internal throttle that you can't see.
Right.
It's adding more fuel to the system, and it's increasing the load.
It's a perfect example at a constant speed because it takes one of the variables away. So the constant speed, you're always turning the same RPM, right? Like he was talking about before. Let's say it's spinning there and doing nothing. As you clamp down on the power trying to be generated by this thing, what has to happen? Fuel has to increase to accommodate the load at that same RPM.
That's correct.
Right.
So
That
makes
is
sense.
correct.
Yeah.
And so that would be the best explanation I could give understanding.
So throttle
Right.
percentage absolutely plays a role in that algorithm,
Absolutely.
along with a bunch of other inputs as well, which can make also load percentage not as valuable or as accurate
Yeah.
as fuel
Right.
burn, which is why we rely so much on fuel burn as opposed to
that's
load.
exactly
The
right.
fuel burn's easier to understand because it's the RPM at the fuel rate at a given RPM, and you can compare that with what you had before or with what the chart says the engine's supposed to do, and it's just two numbers that go together, and then you add with that the speed of the boat, so you understand how you change these things affects your speed too, because you want to know that for fuel efficiency, right? But with those three numbers, that tells you everything you need to know. You don't really need to look at the load percentage because there is some added stuff to the algorithm that can throw people off a little bit.
That's correct.
Yeah.
Temperature can play a role in it too.
Sure.
They use a lot of parameters to measure load percentage.
Okay. Good stuff. So now I wanted to dig in and start talking about the creation and evolution of the SMX seawater pump. So my first question is, it's a big open one. Why did you create your own pump?
Mostly because of the failures.
And try to be a little bit politically correct here.
I will be. In the early versions of the 6 BTA engine, Cummins, when they developed with Sherwood, they developed a larger pump, and let's just call it a 2-inch pump for the sake of making it simple. Had a larger impeller, pumped more water, yada yada yada. When they did that, I use the term they left a lot of room for improvement. One of the first things that we used to see was the water seal that kept the water on the seawater side
Right.
would start to leak. When that leaked, the design of the pump allowed the seawater that would leak past the seal wash the bearings that literally were part of the engine. They were sealed bearings, but literally they supported the shaft of the pump. As they got washed with salt water, the bearings would start to rust and fail. When they failed, it could go from an external rusty leak to where the shaft would start flying around in there, the gear would start flying around in
And
there,
it tried to destroy itself
and
from the
Yeah.
inside
literally
out.
start to destroy itself from the inside out. That was the first thing that we thought we could come up with a better mousetrap. Understanding how pumps work, not necessarily on marine engines, but in all engines, I looked at the situation, took apart enough of the pumps, and decided that, hey, the best thing to do with this seal thing is to move the seal kind of to the other side. In other words, let's put the mechanical seal is going to kind of stay where it is. That keeps the water supposedly on the pump side. But the problem is when that leaked, then we washed the bearings.
Right.
So now what we do is take the front oil seal that normally kept the engine oil out of the pump and put it behind the bearings. So now when the seal leaked, it came up against a water seal to keep the water from washing the bearings. So that required some reconfiguration of the front of the pump a little bit. And after doing some prototype work and stuff like that, I did a couple of things that were directly related to that. I had to increase the spread of the bearings that supported the pump a little
So
bit.
a longer axial
Longer axial
support.
And
You added a bearing.
I initially added a bearing to spread the load. It was also the easiest way to take up the added space because the bearings themselves are cheap. Let's just say they're $10, okay, versus building custom spacers requires more work. So I went with a third bearing and used that bearing to space the bearings out farther, create better axial support. But that also added an additional issue. The actual total length of the pump increased. Now, a lot of people buy our pumps and never notice the difference.
Sure.
In fact, I don't think you noticed it much at first.
I didn't notice.
But in
This is news to
actuality,
me right now.
yeah, in actuality,
learning.
if you take a fixed point on the engine and measure to the back of the impeller plate, this SMX pump is about 5/8 of an inch,
Yeah, it's
3/4,
about half an inch.
half-inch
I
longer.
never knew that.
Yeah, it is.
Close enough to fit with all the
Yeah,
hoses.
not
Right.
that not that it matters because there's no
it-
clearance
it-
issues
it-
anyways. But
It didn't affect installing the hoses. That's the main thing. In fact, it offered a couple of things that helped down the road.
Right.
But for the time being, I didn't even mention it to anybody. And again, people have had the pump for years and used them for years and never even noticed
Yeah.
the difference.
The extra half
But
inch
it's
doesn't affect-
physically there.
Yeah.
It's physically there. So we were able to redesign the pump by adding a secondary way to keep the water that leaked past the seal from hitting the bearings. That was the biggest single improvement. Then, once we did that and put the seal behind the bearings, then we got rid of the sealed bearings and allowed the engine oil to lubricate the bearings.
Perfect.
To me, that is the single biggest improvement to that pump.
Sure.
We have a continuous flush of engine oil. Even though it's black, it's still good.
Not only lubricates but cools.
It
Right.
cools,
There's
it
a lot of
lubricates,
benefits.
washes the bearings, and
That's why you get so many hours
that's
and long life. out of
that
the
is
pump.
probably one of the reasons we've seen many of our pumps go between 5 and 10.
Are you aware? Is the Sherwood pump still designed as it was, let's say, in the 90s? Is it
Yes,
still
they have.
the same?
They haven't changed that.
So the design is just
Still
been
the same.
Okay.
A set of sealed bearings that they're trying to keep the water out of them by putting a water seal that leaks. It's as simple as that.
Yeah.
The mechanical water seals fail. Our mechanical water seals fail.
Well, yeah.
They all do.
Yeah,
That's
it-
perfect. Sure.
yeah.
Sometimes
It's the
we
wear
get-
part. I mean,
Yeah.
Yeah.
Sometimes we get thousands of hours out of them. Sometimes we don't. Sometimes we have an early failure. Luckily, it's the way the pump is designed. It's fairly easy to change
Sure,
the seal.
sure.
In fact, we've come up with a method. In fact, one of the guys that worked for me and still does on and off, Brendan, he developed a way to replace the seal while it's in the pump, literally on the engine.
Yep.
It's tricky, but it's doable.
Sure.
And one of the other things that needed to be worked on the 1730 design, and actually we're still kind of coming up with a version 3 of it, has to do with the front mounting and the clearance that Cummins didn't give it for working on the front mount.
right.
That has been a sore point since day one.
Right. The front bracket on the
The
engine.
front bracket on the engine, they
clearance
designed in
issues.
such a way to where it made it very difficult and close to impossible to even replace the pump. Or
Right.
to
Without
remove
lifting
pump
the engine.
Without
Yeah,
lifting
without
the-
Right,
taking
which
the
is an
front-
absolute
no,
right.
PETA, right?
And
Pain in
so
the, you know what?
Our first designs addressed it 50 to 75%. We redesigned
The flange.
the diamond plate to where it allowed quite a bit of additional clearance and movement to be able to get the mount out, but it was far from perfect. Over the past few months, we're looking at, since we're running low on plates anyway,
Yep.
we're going to redesign the plate and have the proper castings and molds made. We're going to have a new plate design that allows quite a bit of additional clearance to be able to literally, we should be able to, in the worst case scenario, loosen the bolts of the pump and wiggle the pump out of there.
Right.
Without
I think
raising
We'll have a
engine.
lot of happy customers.
Yeah, we'll have a lot of
Yeah, with our early testing, it's looking good. Like we're going to be able to get the pump off without having to take the dang engine bracket off. So
Right. That's been a sore point since day one. This is 100% a Cummins engineering issue that they didn't really think about the replacement of a pump of a part on an engine
In the
that
field.
requires replacement in the field.
Yeah, sure.
And
okay.
I could use much more unpolitically correct language to
Not on
describe
this
what they did,
podcast. Not gonna happen.
but I'm not allowed to do that.
That's right.
I got one. Can you dispel the myth about the Korean knockoff? There's like a Korean, believe it's a Korean pump that looks externally, it looks a lot like ours. And I've seen people in forums say, "Oh, Tony's just selling that Korean pump and slapping SMX on it." And I know, as being the product engineer here at Seaboard, we have over 100 parts that we source every single one of them. Everything's cast just for us. I mean, I could tell you the pump is not. We're not rebranding some other pump. But where did this? What about that?
I'll tell you exactly where the Korean thing came from. The very first pump we had made was made by Seafirst, which is a Korean company I hooked up with over 20 years ago. They helped me. I designed the pump, but their help came from they wanted to make the pump for us, and they really put a lot of effort and expense into developing the tooling to make it on their die.
Sure.
And with that, I promised them I would do X amount of pumps for them. And let's say in the first 10 years of production, we put out well over 3,000 pumps in the field. Yes, we had some learning curves during a run of production. The first year went very, very good. By the second or third year, as the volume increased, some of the manufacturing process fell short on a couple of things. And so we had to we went through some learning curves, and we've solved them all. And since then, other companies, both in China and Korea, made knockoffs of a Sherwood pump and knockoffs of our pump.
Right.
Most of them, I believe, are more Sherwood orientated. The biggest difference, and the easiest way to tell whether it came from our design, not necessarily that we built it, but came from our design, is the two screws that hold the cam.
The cam.
If you see the two screws that hold the cam, then that is either our pump or a complete knockoff
Yeah,
of
we
our
can show
pump.
a picture of that
Right.
too. We can
Yeah.
see the
Right.
difference between
Yeah.
the screws.
When you see a Sherwood pump or type Sherwood pump that replaces the
screw.
pump with a single screw, it's more or less a copy of the 1730 that Sherwood developed
Right.
and their iterations.
So basically, our intellectual property. It's funny because our intellectual property kind of got leaked or stolen or
Right.
borrowed, or however you want to say it.
That's correct.
And then somehow it got around that we were copying them or using their stuff. But it's actually the other way around, because you developed
I developed
the two cam screw pump, the three bearings, that whole design.
Correct.
Yeah.
One of the guys I mentioned earlier, Brendan Catlett, has used a JMP knockoff of our pump that I believe has the double cams, and he doesn't have anything really bad to say about it, other than the fitting of the impeller on the pump is iffy. Some of them you can get them on, some of them you can't. It's very inconsistent. And that's the only real complaint I've heard about that particular
Now,
pump.
am I right? Some of the knockoff pumps that look like ours take a keyed impeller.
That's correct.
Where
And that's
ours are the spline.
ours are spline.
Yeah.
Right.
And the reason they're keyed impeller, that was the original 1730 design.
Right,
And they
right.
stayed with that. And over the years, we developed our own impellers. We ended up working with a company in Italy, CEF, very, very high quality company that mostly deals with automotive parts, from shock absorbers to bushings to everything except impellers. But I noticed that they did have a line of rubber impellers. So I asked them if they could develop our splined impeller for our pump, and they did. And with that came a design that they had developed for pulling the impeller,
The T-puller?
the key puller. That I don't know if it's protected by them, but we like the system.
Yeah, it's great.
And we developed that same system for quite a few of our impellers.
Right.
We think it's very easy to use. It's been very reliable. They never made a good puller for it. We did. They made a plastic puller, but we made a screwed-in puller that we like very much. I've sent them samples of it. I think they did buy maybe a couple hundred of them from us years ago, but they haven't really. I didn't mind if they copied it or anything. It didn't matter. They've been good to us, and I'll do them whatever I can do to help them.
Right. Right. So let's talk a little bit about what's involved in making one of our pumps. So we do all our own. Everything's cast specifically for us. We do all our own engineering. We communicate directly with the manufacturer. Everything's spec to us. We do all the quality control here. We have developed dunk tests and jigs for checking for leaks on our castings and all kinds of
Casting porosity, etc.
Yeah.
A lot of quality
And-
control checks.
stuff. It's our own. We source our own bearings. We have our own cams made. We have our own
Shafts.
flanges made. And we got the new flanges coming that are going to be a little bit more streamlined.
I think you said also we're going to change materials from more of a cast iron to a cast steel.
They want to do a forged steel. Yeah.
They want to do a
The
forged
manufacturer
steel.
wants to do a forged steel. Yeah.
I'm not really
It's
sure.
going to be stronger.
It's going to be stronger. Not that we've had problems, but the fact that we're thinning up the flange a little bit.
It'll be an improvement.
It'll be an
Sure.
improvement.
Yeah.
We don't want to go down in strength.
Right. Right.
And because we are removing material from it to allow easier access of R&R
Right.
of the pump. So this is a good change. But as far as all the parts, we not only assemble the pumps here.
Yeah. We completely assemble them.
We've developed a complete bench for it, literally,
Yeah.
with custom tooling to assemble them. But all the parts are being made to our specifications from various manufacturers in different places of the world.
How many parts?
And
is
like I
there?
said, there's over 100 sub-assembly parts that
Right.
make
Yeah.
up one pump.
Right.
From the back of the pump to the front, it takes 100 sub-assembly parts to make that thing a
Right.
complete.
Yeah.
And
working, functional
some of our parts are made here. Our stainless steel backing plates are made. I've had them made literally locally at a local CNC shop that does water jetting. I think now
We're making our wear plates in house now because we have a water jet.
Yeah, that's right.
So we've
we
been
make
making
our own wear plates. We've
out of
invested in
316 stainless steel.
right, and so I can't really say it's a made in USA pump, but let's just say this: it's as made in USA as you can buy anything
Well,
today.
it's definitely assembled in USA. I'll
Yeah,
tell you that.
That's for sure. It's assembled in the USA.
Yeah.
And I really haven't looked into what you can claim is made in USA versus, is it a percentage of the parts?
Wow.
Is it the weight?
Yeah.
Is it the cost? Don't know what it is, but it's as made in USA as you're ever going to get. Certainly compared to anything Sherwood offers.
Right, right.
None
It's
of
an
their stuff
SMX
is made
pump
here.
through and through.
Yep.
That's for
It
sure.
is an SMX pump. So we could say this: when you have a problem with it, the buck stops here.
Yeah.
That's right.
And
That's
you're
right.
looking at them.
Right. And we support that pump because we have every single part of those 100 plus pieces. We have every single one.
And there's a few videos out there too that show you, various things about how to remove impellers, how to install impellers, how to internals of the pump, how to replace seals and things. So it's a well-supported product, right?
And
That's the whole idea.
We got more videos coming, and we're going to change our product lineup a little bit for our major and minor rebuild kits. And we're developing some videos and some content to help you guys maintain those pumps. So that's coming soon.
And I'm going to throw out an idea as you guys are talking. I think one of our episodes in the near future, we are in the process of building a new machine shop, and it's going to be quite nice. And we talked about the water jet. We talked about making our own parts in-house. So I think we need to do a tour pretty soon of the machine shop
Yeah, once it's
and
all-
what's involved in making some of these parts and how we go about quality control and so on and so forth.
Good idea.
So stay tuned.
Okay. Well, did you have any other topics or questions for Tony?
Yeah,
Anything you wanna add?
I want to add one more thing on the development of the pump over the issues that we have with the Sherwood, and I didn't mention it, but I'm going to mention it now. One of the things that the Sherwood pumps did was the inner wear plate would not stay in place. It literally, the pin that held it from rotating would shear off. And when it did, the inner wear plate turned into a saw blade.
Right.
Literally. And would saw through
We have
the
pictures
housing.
on the website
Oh my
of
God.
it actually
And
going through the bronze housing.
I saw many of
Oh,
those
wow.
over the years.
Yeah.
But mostly because the issue was once that pin sheared, you'd lose pumping quality.
Right.
Plus, the material of that plate was a common brass, and it just didn't hold up. It'd get grooves in it. Grooves would lead to one thing or another. One of the first things we did was in developing the pump was start using 316 stainless for the inner wear plate,
Yeah.
and 2, develop a locking design that utilized a space that was built into the pump with a special tab. So once our plate is installed, you have 0 issues.
It can't spin.
It can't
Yeah.
spin no matter what happens. And 2, the actual wear of the plate went from something that was a very fast wear item to where it literally lasts thousands of
I'm
hours.
assuming that Sherwood at this point has probably mitigated the spinning wear plate issue. We don't.
they
tend to see it
increased the
anymore.
diameter of the pin only.
Oh,
They
okay.
went from about
So now it won't. It doesn't shear as
As
easily.
easy.
yeah,
yeah.
right. They went from
Okay.
about a 3/36 diameter pin to a 1/8 inch pin.
Okay.
The last time I looked at a Sherwood pump, it had about a 1/8 inch pin. Same problem though.
Yeah.
Same crap material they make then.
All right. Well, thank you for joining us today.
fun.
We'll probably have you back on a.
We're gonna
on
have
an
him back.
episode.
We're gonna
Let
have
us
him
know
back.
if you want to see Tony in more episodes.
And send us, boattalk@sbmar.com. Send us everything. Send us questions, things you want to know, things you want to hear from Tony, and we're gonna bring him back on and hopefully have a nice, well thought out list of questions that we can get some of Tony's feedback on.
Yeah. So, well, thanks a lot.
Thank you. Corey, there you go.
Yeah, go back to work.
I'm going to go back to work and
Go make some money.
earn my keep.
Got to pay for this podcast somehow. All right. Well, thanks for listening to Boat Talk. Great guest, right? It was great having Tony.
He is the guest. He's
He
the
is.
quintessential guest. He's the guy. He started. I mean, we wouldn't be doing this if he didn't start it all off. Back in the '80s,
Right?
walking the docks, doing all the things that he did, and coming up with all this crazy products and ideas and stuff.
Thinking outside the box.
We're here. We're carrying the torch, and I'm glad that we had him on today.
Yeah. And if you want to see more of Tony, just email us, and I'm sure he'd be happy to come on if he knows you want him. So
That's right.
let us know. So if you have any ideas for segments, again, we need your submissions. We're at this point, we're still answering every email. So email us. We're accessible. boattalk@sbmar.com. And let us know if you have a good story for one of our segments, our cautionary tales or harrowing tales. What do we call that one? We call that shaft log.
Shaft log.
And then between two sterns, funny stories. If you got a good funny story, send it to us. We'll read it on the air. And you can reach us at boattalk@sbmar.com.
Send us everything.
Thanks for watching.